Imagine the deep, unlit ocean of space. Quiet, endless, and cold. Out there, somewhere beyond the last familiar star, there are realms where the rules we rely on simply stop working. Where time doesn't behave, where space folds, where cause and effect seem to swap places and stare at one another. At the heart of that strangeness lives a creature we named long ago, the black hole, a thing that eats light and forgets it, a place where what goes in does not come back. Now let your mind tilt, just a little. What if all of this, every galaxy you've seen in pictures, every radio whisper from a distant quasar, every atom in your hands, what if it all rests inside one of those dark engines? Not beside it, not orbiting it, inside it. Imagine our entire observable universe as the interior of a cosmic vault, a prison so perfect its walls cannot be touched, cannot be crossed, cannot even be pointed to. Recent images and measurements from the James Webb Space Telescope have stirred that question in new ways, revealing patterns that feel less like the roll of dice and more like the trace of a hidden design. If the universe were purely random, some of these patterns would wash out. Yet they do not. So we breathe in, breathe out, and prepare to follow the thread. This is a journey you listen to with your eyes half closed, the way you listen to rain. We begin. Picture a doorway that closes behind you with no handle on your side, no seam, no sound. Once you pass through, you do not return. In black hole language, that door has a name, the event horizon. It isn't a surface you can bump into, it's a rule. A one-way rule that says, past this boundary, escape is impossible. Even light, the universe's fastest messenger, finds no route back. Everything curves inwards. Everything moves into a fall that never ends. Around every black hole is this perfectly indifferent ring of no return. Its size is not mysterious. It scales in a simple, unnerving way. Feed the black hole more matter, and the horizon grows. Double the mass, double the diameter. 10 times the mass, 10 times the width. It is a straight line rule that holds from small, star-sized holes to the giants that haunt the centers of galaxies. No trick to it, no exception anyone has seen. Here, then, is the turn in the path. Astronomers take the mass of everything we can, in principle, observe. Stars, gas, dust, the dim hum of background radiation, dark matter's hidden weight, and ask a clean question. If all that mass lived in one black hole, how large would its event horizon be? The calculation lands on a number that makes the room fall quiet. Roughly 93 billion light-years across. That is, astonishingly, the same scale as our observable universe. The farthest edge from which light has had time to reach us since the beginning. The line where we stop seeing, not because there is nothing beyond, but because no signal has had long enough to arrive. It would be tempting to file this away as a nice curiosity, a statistical coinciding of two big numbers. Yet the echo runs deeper. Average the density of matter across our observable cosmos, add it all, stir it all, spread it evenly, and you get a value that aligns with the density you'd expect inside a black hole with that very horizon. It is as though our universe has been tuned, quite precisely, to the recipe for gravitational collapse, as though a hand, if there were a hand, pressed it down to just the right thickness. And still, here we are, gently breathing on a tiny blue world, discussing it. Einstein's general relativity tells a further story about what might exist inside such a collapse. The equations don't whisper destruction as their final word. They point, surprisingly, to continuation. Under certain conditions, space and time do not stop at a point. They reopen. If one could somehow pass through the throat of a black hole without being torn apart, one might watch the entire future of the outside universe play in a compressed flash behind, while ahead a new region of space inflates and flowers. A fresh cosmos unfolds, carrying on as if nothing had ended. And this raises a question that touches the edges of sleep. Could we be the residents of that other side? Are we the descendants of a collapse we can never again contact, living in rooms constructed by a parent we will never meet? Our universe shows a set of carefully balanced beginnings. Not a crash of random values, but numbers that look chosen. The strength of gravity, the charge of the electron, the geometry that guides how light travels and how mass curves the fabric it moves through. There are hints even of something like spin inherited from a mother world, a long, gentle swirl imprinted on the largest scales. If that picture is true, then each black hole we see may be more than an ending. It could be a cradle, one-way and silent, containing a whole new cosmos inside, each with its own physics within allowable ranges, each with galaxies and dark nights, and perhaps even thinking beings, all sealed away by the horizon's absolute border. They would never see us. We would never see them. Yet their skies would be as real to them as ours is to us. To trace how this thought took shape, we step back to 1965 and to a mathematician's quiet certainty. Roger Penrose proved, under very general conditions, that when matter collapses under gravity, a singularity forms. A place where density becomes infinite and physical law loses its grip. Stephen Hawking and others carried that thread forward, tying it tightly into our understanding of black holes. The world accepted that inside those horizons, collapse ran to completion. Matter squeezed to zero volume. Time, as we experience it, gave up. But those theorems, powerful as they are, live in the classical picture, where the world is smooth, continuous, and obedient to forces we can write down cleanly. The quantum world, the reality of very small things, does not resemble that picture. There, particles refuse to pile up in the same way. They obey what's called the exclusion principle. You can think of it as the universe's own crowd control. Particles of the same type won't sit in the same state. They won't queue in the same chair, even if gravity insists. No matter how hard you press, certain arrangements are forbidden. Follow that rule into the heart of a collapsing mass, and something evocative happens. Calculations that include quantum pressure, this resistance to identical particles sharing the same state, show that the inward rush cannot continue forever. As the collapse deepens, the quantum pressure grows, and at some absolute maximum density, the fall is arrested. Not just paused, but reversed. The matter rebounds, not because of a new exotic force, but because two known parts of physics, general relativity and quantum mechanics, are allowed to speak at once. The bounce is not hand-waving, it is mathematics. What rises from that rebound is not a shredded remnant, but a new expanding region of space. And the expansion, when traced in detail, does something familiar. It undergoes an initial breathless acceleration, akin to inflation in standard cosmology, smoothing and flattening the newborn universe, then later experiences a gentler, persistent speeding up, reminiscent of what we label dark energy. In this story, neither inflation nor dark energy need be mysterious additions. They are natural consequences of the bounce itself. Creation driven by compression that could not continue. If so, then the event we call the Big Bang may not mark a beginning in the absolute sense. It may be the moment of maximum squeeze, the turn from inward to outward, the instant the cosmos inhaled after holding its breath for too long. In that case, we live not at the start of time, but in a middle chapter. Collapse, rebound, expansion, structure, collapse somewhere else. An ongoing cadence, like tides in a harbour too large to picture at once. The universe that compressed to make ours would leave faint fingerprints on our sky. It would set the initial geometry. It would tune the constants. And if it had spin, if there were a preferred direction, it might pass a whisper of that rotation into us. Which brings us to a quiet office and a set of images that seem too simple to mean anything. At Kansas State University, a computer scientist named Lior Shamir examined the most modest of features, the winding direction of spiral galaxies in the deep sky. If the cosmos is, on average, symmetric and unpreferenced, then one expects equal numbers of spirals turning left and spirals turning right, with any local clumps of imbalance washing out across immense samples. But in datasets drawn from the James Webb Space Telescope's deep surveys, that equal balance appears to tilt. In a collection of hundreds, a clear excess turned one way rather than the other. The numbers matter, but it is the pattern that lingers. The preference is not extreme, yet it is statistically stubborn. It shows more strongly at greater distances, which in cosmology also means earlier times, a glimpse of the young universe, still bright with first structure. The asymmetry even behaves differently in different parts of the sky. It is as though there is a very long axis somewhere, and we, by accident of where we sit and how our galaxy is tilted, catch its hint. To guard against human bias, against seeing a pattern where none exists, Shamir used a fully automated method. Images became radial intensity plots. Spiral arms became measurable curves. Their handedness became a number. The algorithm made the same decision every time, in the same way, for any scientist who cared to replicate it, and still the imbalance refused to go away. If the preference is real, and cautious researchers will keep testing it with larger samples, then the cosmological principle, our starting assumption that the universe looks the same in every direction on the larger scales, would need to be softened. Not abolished, perhaps, but given a caveat. There is a gentle twist to things, a faint preference. The universe is mostly even, but not perfectly so. What could sow such a preference? In small systems, rotations grow because of tiny initial nudges. A skater pulls in her arms and spins faster. A cloud collapses under gravity, and any whisper of spin is amplified. That is conservation of angular momentum, a rule as steady as any in nature. But on the scale of everything, where would that first nudge come from? If there is no outside, who supplied the spin? Here the black hole picture offers a neat bridge. Black holes are remarkably simple at the level of exterior description. If you stand outside the horizon and measure carefully, you can characterize a black hole by just a handful of numbers. Mass, spin, with charge theoretically possible, though astrophysically negligible. Everything else, how it formed, what it swallowed, the messy details, gets erased by the horizon's austerity. If our universe is the interior of such a rotating object, we would expect it to carry, in some subtle but global way, the memory of that rotation. A cosmic axis would be built in. Locally, it would be too small to notice. Over billions of years, across a volume so large it takes numbers to contain it, the preference might bloom into patterns in the way galaxies wind. This isn't a lone speculation. For years, some theoretical physicists have explored models where matter falling into a black hole does not die at a singularity, but rebounds into a new, causally separate universe. From the outside, that parent object would look like a black hole, opaque and one way. From the inside, the newborn cosmos would simply be all there is. The connection would be mathematical rather than traversable. The parent, if you could view it from inside, would resemble a white hole, the theoretical time reverse of a black hole, an object you cannot enter but which emits matter and energy. But you cannot look out. The horizon forbids it. Light launched from interior regions never crosses that boundary. It curves back and continues its life inside. This vision reshapes the map of reality. Every black hole we observe could be a seed, a doorway, a cradle for a universe that will never know its origin story in any concrete way. Each offspring would inherit some basics from its parent: the mass that sets scales, the rotation that sets a quiet axis, perhaps even slight differences in constants that alter chemistry. Within those rooms, stars would gather, planets would weather, life might look up and wonder, asking versions of our own questions. They would have their own night skies, unfamiliar and yet perfectly ordinary to them. When James Webb lifted its gold mirrors to the sky in 2022, it didn't simply sharpen Hubble's view, it changed our reach. Infrared vision let it look past veils of dust to older light, stretched thin by cosmic expansion, arriving from a time when galaxies were sparse, small, and restless. In that flood of ancient photons lay tiny twists of structure, the way arms curl, the faint offset of bars, the soft blur that, under a careful algorithm, resolves into left-handed or right-handed spirals. The power lies not in any single image, but in the ability to gather many, to measure them consistently, and to let statistics speak in the quiet way statistics does. Projects like JD's, the JWST Advanced Deep Extragalactic Survey, build upon decades of groundwork. They aim their lenses where the sky has been stared at before, layering depth upon depth so that comparisons can be made cleanly. The result is a catalogue not of pretty pictures alone, but of data that can be weighed and tested and challenged. When automated analysis such as Ganalyzer sweeps through these collections, it produces numbers that any team can check. And when those numbers lean again and again in one direction, curiosity awakens. If the asymmetry holds up under more data, if it remains after all the careful corrections astronomers apply for selection biases, instrument quirks, and the hazards of small samples, then we will have learned that there is a preferred direction sewn into our cosmos. Not a compass-bearing one can follow from here to a center. There is no center in an expanding, homogeneous universe, but a global property, a faint twist, detectable only in the grand average of things. That would be a prompt to rethink, to ask how our largest scale theories should be adjusted, to entertain seriously the idea of a parent rotation echoed within. The mathematics that describe this possibility do not require special pleading. In Einstein's framework, a rotating black hole is a standard, exact solution. It drags the fabric of space-time around with it. It sets up regions where motion is not optional. Space itself carries you along. If you scale such an object up to contain the mass equivalent to our observable universe, the size of its horizon, again that stubborn 93 billion light-years, matches our horizon. The average density inside matches the average density we infer. Add quantum pressure to prevent singular collapse, and you have a recipe for a bounce into expansion. The greater the mass, the larger the interior room. There is no upper ceiling to that in the mathematics. There is only proportion. We are, in this view, residents of nested horizons. The first is familiar. Our particle horizon, the limit to what we can observe because light has had only so much time to travel. Beyond that limit, the universe may continue, but its stories have not yet reached us. If we live inside a black hole, there is a deeper horizon, the event horizon of our cosmic container, that we will never see even in principle. It is not merely far away, it is causally sealed. No signal sent from here, no matter how early, ever crosses it outward. We can place no instrument upon it. We cannot scan it. It is a border written into the geometry, not a wall in space. This enclosure bends our usual language. In standard cosmology, we picture an open universe, expanding without edge. Space is not expanding into something, it is simply becoming more of itself. But if our cosmos resides within an event horizon, then in a more complete sense it is bounded. The boundary cannot be approached. It cannot be tested. Yet it exists in the equations as surely as a coastline exists on a map, dictating what routes are possible and which are not. From the parent universe's perspective, if such an outside exists in any communicable way, our entire long history would smear into a blink. Near a horizon, time dilates. Processes that feel slow inside can appear fast outside. Stars would flare and fade. Civilizations would rise and fall in a flicker. But inside, where we live, time flows the way it always has. Seconds stack into minutes, into years. Children grow. Ice melts. Telescopes integrate faint light that has traveled for billions of those years. We can write our equations and point them outward, and still the event horizon that contains us stays hidden. Not beyond reach, beyond relevance. It does not enter our experiments. It shapes what is possible without offering a surface to touch. As you drift with these ideas, let your breathing slow. The thought is grand, but it does not demand excitement. It invites a calm attention. If each black hole is a seed of elsewhere, then the night sky is heavy with unopened rooms. If we bear an inherited swirl, then it is only the faintest murmur, felt not in a laboratory, but in a census of galaxies far away and long ago. And if our universe is held by an event horizon, then the story of our origin includes both an ending and a beginning at once, stitched together by laws we already know, sung in a register we are just learning to hear. Quietly, without fuss, a small request. If you're enjoying this gentle voyage through the deep, and you'd like more nights like this, do consider subscribing to and liking Space Historian. It helps keep the lantern lit for the next journey. We live then with horizons, with boundaries that define not our hunger to know, but what there is to be known from here. The cosmic horizon, set by time's age, curves around us like a sphere made of light's patience. The event horizon, if it is real for us, sits forever out of view, a promise written into geometry that the outside will remain outside. And still we look up, measure, compare, wonder. We do not need to escape to understand. We need to listen closely and let the numbers tell their soft story. This imprisonment isn't just theoretical. If our entire cosmos is the inner chamber of a single black hole, then every black hole we point to in our night sky becomes more than an end. It becomes a beginning. Each one could cradle its own private universe, thick with its own galaxies, suns, and perhaps minds that look up at their own darkness and wonder. Those pocket worlds would be perfectly sealed, one from another, the way shells hide their pearls. No messages crossing, no machines tunneling through, each reality complete and alone. It's an infinite nesting of rooms within rooms, a hall of mirrors built from gravity itself. And if James Webb's curious hint that distant spirals prefer one-handedness over the other endures, then we may be hearing the faintest knock from outside, a built-in twist, a cosmic fingerprint pressed into the fabric we inhabit, marking the spin of the black hole that birthed us and preserved across eons like a signature in drying lacquer. Of course, this thought brings a quiet unease. If there is no door through which to step, if no message can ever reach the world that made us, does our confinement change anything we touch? Chemistry still behaves. Biology still learns. Stars still fuse, planets still drift, and minds still dream. Perhaps the deeper shock is not the prison, but the plurality. Our universe is one bubble among countless others, each tuned just enough to light its own stars and raise its own questions, each sealed by the same one-way law that keeps horizons honest. At the center of this black hole cosmology sits a shimmering, mind-bending twin: the white hole. If a black hole is a throat down which everything falls and nothing returns, a white hole is the reverse. A fountain that only gives, unable to be fed from outside. Einstein's equations allow both shapes. They are mirror images permitted by the same mathematics. We have not seen a white hole in our sky, but if our reality truly lives behind an event horizon, then that mirror must matter. In this picture, the Big Bang is not an explosion from nothing. It is the inside view of a white hole outflow, the moment our room opened and everything rushed outward. Imagine the story then as an elegant loop. Matter and light in some parent universe collapse past a point of no return. They move through a region so warped that time and distance lose their everyday meaning. On the far side of that fall, the tide turns. What was inward becomes outward, and a white hole birth races open, the first light of our own cosmos. From that birth, galaxies condense, stars ignite, and the slow dance of chemistry begins. The white hole in this telling is not a thing we can point to. It lives beyond any horizon we could ever see. It is the past we approach in measurement but never touch, always a little further than our latest telescope can reach. This bridge explains old puzzles in a fresh voice. Take the cosmic microwave background, the afterglow that floods the sky with a near-perfect uniform temperature. In the black hole to white hole tale, that smoothness is not a coincidence that demands new fields and forces. It is the natural imprint of a single collapsing region giving birth to everything inside us. Stretched and cooled by expansion, the last light from that birth remains as a quiet, even hum. It also explains why time seems to prefer one direction. The white hole opening lays down an arrow. Causal threads run from that bright beginning forward, allowing complexity to grow, entropy to increase, and stories to be told in sequence rather than reversed. Quantum ideas strengthen the bridge. When you let quantum pressure speak inside gravity's equations, the headlong crush toward a classical singularity halts at a maximum density, then rebounds. That rebound looks precisely like a white hole phase from the inside. No exotic additions required. Known physics prevents infinite compression and turns collapse into creation. What appears to outsiders as destruction becomes, on the far side, a release. A brand new space whose first act is to expand. Follow that logic to its natural consequence and every black hole becomes a doorway. Our Milky Way's central giant, millions of solar masses gathered into a span smaller than our planetary neighborhood, would, inside its horizon, shelter a whole universe. Not a smaller one in any meaningful sense, but a complete cosmos with its own age, its own deep sky, its own inventory of atoms and worlds. Whoever might live there would not know we exist. They would chart their horizon, map their microwave afterglow, and build their own instruments to peer backward into their early light. One evening, perhaps, they would notice a small imbalance in the way distant spirals wind, and wonder if they carry their parents' spin the way a child carries a family resemblance. And in their interior worlds, black holes would form again. Each would open to another room, and those rooms would harbour their own black holes, cascading down without end. The ladder runs both ways. We are nested inside larger structures that are nested inside larger still, while within our own skies lie throats to innumerable elsewheres. The mind tries to picture the scale and simply drifts. The numbers run out of breath. In our visible slice alone, we count on the order of 100 billion galaxies. Each galaxy hosts millions to billions of black holes. If each is a seed of a new cosmos, then our one universe acts like a nursery, giving rise to more universes than there are stars in any single spiral arm. And every one of those nurseries breeds its own nurseries, endlessly. This is a multiverse of a different flavour than the one popular tales propose. There is no need to tuck extra dimensions behind curtains or layer parallel sheets at imperceptible offsets. The nesting happens within the three-dimensional fabric we already know, divided only by horizons that no signal crosses. Communication fails not because we lack engineering, but because geometry refuses permission. If life blooms easily given enough time and energy, then such a cosmos is saturated with it. Not here, not next door in the literal sense, but everywhere in principle. Each world sealed in its own story, the way books share a shelf, yet never bleed ink into one another's pages. Minds rise, look up, argue, write, love, solve, and fade, never aware that just across an uncrossable line, other minds are doing the same in the neighbourhood of different suns. As our speculation completes a quiet circle, we can lay out the clues that set us walking. First, the eerie match. The size and average density of the region we can observe line up with what the equations predict for the interior of a black hole with the same mass. It isn't a casual resemblance. Within uncertainty, it is a fit. Second, that whisper from James Webb's deep fields. A preference in the way far spirals turn, as if the whole sky remembers a gentle spin. Third, the quantum bounce that removes the impossible infinity at a black hole's center and replaces it with a bridge to an expanding interior, an expansion that naturally carries two accelerations, the furious smoothing of the earliest moments and the quiet late-time push we name dark energy. There's another virtue. This picture tidies multiple mysteries at once. The uniformity of the microwave background, the Goldilocks values of physical constants that let atoms hang together and stars burn stably, and the two-stage acceleration of expansion all flow from the same simple cause, a gravitational collapse transformed by quantum pressure into a birth. Known pieces, new arrangement. But honesty asks for caution. Measurements can mislead. Selection effects can play tricks. The rotation asymmetry in galaxy spirals might be a mirror held at an angle rather than a deep truth about the cosmos. Our vantage point is not special, but it is local. We ride around the Milky Way at hundreds of kilometers per second. Motion changes what we perceive. Waves shorten in our direction of travel and lengthen behind us, that old Doppler shift that makes sirens rise and fall. Translate that to light moving across billions of years, and you can imagine how brightness thresholds might favor one-handedness of spiral over another, especially at the limits of detectability. If galaxies turning one way appear a touch brighter in directions aligned with our motion, they slip more easily into our catalogues. Those turning the other way fall out more often at the faint edge. Map the sky, and you might find the largest imbalance where geometry lines up with our galactic poles simply because of how we move. This mundane account has teeth. It would force recalibrations across cosmology, distances inferred from brightness, ages pegged to those distances, perhaps even the subtle tensions we wrestle with when we measure the expansion rate by different means, but it has an obstacle. Independent determinations of our motion and speed, through the dipole in the cosmic microwave background and other methods, suggest the effect should be too small to carry all the observed asymmetry. So we are left with a fork in the path. Either our understanding of these motions needs sharpening, or the asymmetry is a true cosmic imprint. The stakes are not melodramatic, they simply determine which story we keep reading. there is still a gentler, older clue that you can feel in your own hands. If the black hole birth picture is right, then we are made from another universe's endings. The carbon in our cells, the oxygen we borrow with each breath, the iron that threads our blood, those atoms were forged in furnaces that shone before our sky existed. They fell into a gravity well in the parent cosmos and crossed a horizon we cannot see, carrying their history as elements but leaving their particular arrangements behind. On the far side, in our room, those elements recombined into new stars and planets, and one day, into you, listening in a darkened room, letting these thoughts slow your heartbeat. Not every kind of information survives such a passage. Horizons are ruthless editors. But some global features can be inherited. Spin is one. If the world that collapsed had a preferred axis, the child world may carry a ghost of that direction in its large-scale averages, the way an accent persists across generations. Perhaps some of the constants we treat as givens, numbers that set the strengths of forces and the masses of particles, are not plucked from a lottery but conditioned by the collapse itself. In that case, the uncanny fitness of these numbers for building complexity would be less a miracle and more a memory. Universes that could not make stars leave no descendants. Universes that do. Even the microwave background's almost perfect sameness becomes less odd. In the standard picture, we invoke a burst of violent stretching, inflation, to iron out temperature differences across regions that could not otherwise have coordinated. Here you begin with a single collapsing domain feeding a single birth. Smoothness is baked in. The afterglow we measure is simply the cooled, stretched light from that one region's transformation. Time, too, joins the conspiracy of concealment. Near any horizon, time plays favourites. For us inside, the span from first light to the long fade in the far future is a real procession measured in billions of years. But to an outside watcher, if such a watcher could exist and gaze upon the process from the parent world's side, that entire procession might look like a flicker. That is not contradiction, it is relativity's ordinary strangeness. Different observers carve time differently. There is no master clock that forces agreement. Thus our universe can be genuinely ancient in here while being momentary out there, and both descriptions are true in their own frames. This duality also explains why the horizon that binds us is undetectable in practice. It is not merely too distant, it is defined in a way that forbids return signals. Light launched from our side cannot claw back through that one-way surface. Even the act of approaching the boundary would play tricks on what you could witness. In principle, speaking only in thought experiments, if you could ride arbitrarily close to that outer horizon, you would watch the entire future of everything unfold at absurd speed. Galaxies merging, stars burning out, black holes evaporating into a thin hiss. It would be a time-lapse of the cosmos, played so fast it becomes a single gesture. For us at home, time would continue with its usual stride. For the rider, the film would be nearly over before it began. Through all of this, let the cadence stay soft. These are large ideas, but they ask for quiet, not breathlessness. And if this kind of night sailing through deep questions helps you ease into sleep, it would mean a lot if you subscribe to and liked Space Historian. It keeps these lanterns lit and the maps unfolding at a gentle pace. In the end, the question of our imprisonment may be more about language than walls. We have horizons, and they are real. They limit what can be known from here. But within those limits, the universe remains generous. It lets us test, doubt, refine, and sometimes be wrong in interesting ways. Whether the final shape of the story is an open, infinite expanse, or a bounded interior resting beyond a one-way shore, we are still the same attentive creatures, watching for patterns in a thin rain of ancient light, gathering clues, and setting them beside one another to see if they point in the same direction. And when they do, we follow, not with urgency, but with care, step by step, thought by thought, all the way to the edge of what can be said aloud before the rest fades into gravitational collapse. Imagine a realm forever outside our reach, a level of reality we can neither test nor touch. In such a hidden expanse, the smallest scales behave like a restless sea. What looks smooth to us from far away, space, time, causality itself, becomes froth and spray when viewed up close. Physicists have a name for this churning substrate: quantum foam. It has never been directly seen, but it rises naturally from the rules that govern the microscopic world. In that foam, space flickers, time trembles. Little bridges wink in and out before they can be counted, like bubbles that form and burst too quickly to name. In everyday life, the fabric of space-time seems calm. Roads are straight, clocks behave, distances hold still. But in the quantum regime, the geometry turns skittish. Pairs of virtual particles come into being and vanish again in intervals shorter than thought, borrowing a breath of energy from nothing and then repaying it before the cosmos notices. Regions of space swell and shrink by amounts too small to see, stitching fleeting tunnels between faraway points, only to seal them again almost immediately. It's noise at the foundation, and yet it is lawful noise, the hum of uncertainty playing on an instrument as old as reality. When matter rushes inward toward the core of a black hole, gravity drives it to densities where classical intuition breaks. There, the foam is no longer a faint background rustle. It becomes the main voice. Quantum rules, especially the ones that forbid identical particles from piling into the same state, push back. That push is often called quantum pressure, and you can picture it as a spring under colossal compression. Squeeze it further, and the resistance grows. Press it to the limit, and the spring does what springs do. It pushes out with fury. In this telling, collapse cannot run to infinity. Before the mathematics becomes impossible, before the story ends in an unphysical point, the pressure wins. The inward storm turns outward. What we see as a beginning, a big bang, would then be the inside view of that rebound. Not an explosion into pre-existing emptiness, but an expansion within sheltering walls. Our room opens and inflates on the far side of the fall, protected from the parent world by the one-way veil of the event horizon. The same quantum mechanics that sets the shapes of atoms, the same rules that allow chemistry to bind and life to try, steps in at the abyss and refuses an impossible singularity. No need for unknown forces. The known principles suffice when allowed to speak at the highest densities. Calculations explore where the turn happens. They point to a critical density that is beyond ordinary comprehension, yet still finite. A threshold at which gravity yields to quantum pressure and collapse becomes creation. At that point, the spring releases. Space stretches. Time moves forward into a new chapter. The universe that seemed destined for a final crush blooms instead. The foam also carries memory. The fields that ripple at the Planck scale do not forget what fell. They can record global traits of the collapsing matter: overall spin, electric charge, the pattern of constants that shape what is possible for atoms and stars. In the rebound, those traits appear again, not as the original objects, those particular arrangements are gone, but as inherited parameters. You might think of it as a kind of cosmic heredity. The child universe does not resemble the parent in detail, but it speaks with a recognizable accent. If this picture is faithful to reality, then every black hole becomes a nursery. Not a maw that ends stories, but a discrete ward where new ones begin. The final pages of a star, a cluster, even a galaxy in the parent world are torn out and pulped at the horizon, then recast as blank paper on which another cosmos writes itself. Our universe would not sit alone on some great shelf. It would be one volume among uncountable others, each wrapped in its own horizon, each conceived in the same foaming workshop at the edge of what can be. Deeper in the equations lies a startling corollary, the holographic principle. It proposes that everything within a region can be perfectly described by information on its boundary. Imagine a sphere. Instead of needing data for every point inside, you can, in principle, store all that is necessary on the surface, like a cosmic hologram projecting a three-dimensional scene from a two-dimensional record. If our entire cosmos lives inside an event horizon, then all we see, the galaxy's webs, the light between them, the particles in your breath, could be the interior rendering of information written on that enclosing skin. A projection not in the sense of something false, but in the sense of a complete image encoded with depth, motion and texture, reconstituted faithfully within. Holography emerged from a puzzle that once threatened to split physics in two. Quantum theory insists information is never truly lost. It may be scrambled or hidden, but it persists. Black holes, by contrast, seem to swallow information without trace. How could both be true? The answer that calmed the waters is subtle. Information is not destroyed inside a black hole. It is re-encoded on the horizon. From outside, the boundary's bits change in a way that, in principle, preserves every detail about what fell in. The horizon becomes a ledger that never forgets. Turn the idea inside out, and it whispers something intimate about us. If we inhabit the interior of such a structure, then the richness of our three-dimensional experience may be the unfolding of patterns etched on a two-dimensional surface that we can never approach. That does not cheapen the experience. A perfect hologram contains everything necessary for the scene to be real for its inhabitants. Our hands still feel solid. Our thoughts still bloom. The principle simply relocates where the bookkeeping is kept, and it suggests why the universe has the dimensions we measure. A spherical boundary naturally projects to an interior with three spatial directions unfolding with time, the way a shadow can depict volume when cast correctly. An even odder implication follows. The amount of information any region can contain is limited by the area of its boundary, not by its volume. That cap prevents true infinities from entering the story. It's another way of saying the equations refuse singularities. Before the bookkeeping would demand more bits than the boundary can hold, the physics changes course. The bounce happens. The ceiling on information density is the guardrail that keeps the narrative on a road we can follow. Apply this to every black hole and you get a universe of universes, each interior a hologram painted by its own horizon. Each contains its own versions of suns and stones and perhaps selves, beings who never suspect that their world is an exquisite interior rendering of data written where they cannot see. Their questions would be our questions. Their certainties would be local, like ours. Now consider one of the great shadows in our measurements, dark energy. It seems to fill space with a tiny uniform pressure that makes expansion accelerate. It dominates the cosmic budget, yet it is ghostly, felt only through its influence on how galaxies drift apart. Many explanations have been offered, from new fields to tweaked gravity. All stumble on the same oddness. The energy density required is absurdly small and weirdly constant. But if we live inside a black hole's interior, the acceleration we attribute to a mysterious dark agent, might instead be an effect of global geometry. The inner structure of such spacetimes naturally stretches paths in a way that, from within, looks like a push on the fabric itself. No extra substance required. The shape of the room does the work. In this view, the smoothness and uniformity of the acceleration makes sense. It is not a local field with lumps and ripples, but a property of the entire enclosure. Even the timing aligns. The shift from matter-dominated dynamics to geometry-dominated expansion arrives when the room has grown and thinned to the point where curvature's quiet hand becomes the leading influence. The measured value of the acceleration is not a lottery win. It falls out of the mass and size of the black hole that contains our observable domain. There is a chill in that elegance. If acceleration is a structural fact of our prison, it will continue. Galaxies will slip from one another's sight. Island universes will drift alone in an ever emptier night. Stars will end without replacements, and complexity will thin. The same geometry that made space hospitable to structure will, over very long time, unmake it. The walls protect, and the walls isolate, and the walls guarantee an ending we will not witness but can infer. Underneath all of this runs an argument about information's fate, quantum mechanics' strict conservation versus the apparent erasure by horizons. That debate once burned hot enough to threaten the unity of physics. If information truly vanished, quantum theory would need rewriting. If it did not, black holes would need new bookkeeping. Holography offered the compromise. Information is neither lost nor returned in its original form. It is transformed and stored on the boundary. In our story, the resolution becomes grander. The information that fell into the parent black hole is not only preserved at the horizon, it is also re-expressed in the interior as a new expanding cosmos. Galaxies, stars, and living minds inside carry that preservation in their very being. We ourselves are the continued existence of information from elsewhere. This has a way of bending the mind toward questions about identity. If the patterns that define you can, in principle, survive the destruction of arrangement in one world and reappear in a different guise as part of a broader geometry, what does ending really mean? It is not a promise of survival in any personal sense. It is a reminder that reality is stingier with true loss than we often think. Information transforms. It does not simply fall silent. Holography also blurs the border between worlds. Horizons are stern, but they are not absolute in the sense of severing logic. What exists beyond can still constrain what is within through inherited parameters and boundary conditions. Our constants, our initial smoothness, perhaps even our faint large-scale spin, all may be letters from before, folded into the envelope of our universe at birth, which brings us gently to the one subject that never quite fits inside equations: consciousness. If our reality is an interior reconstruction of information encoded on a surface, if space-time and fields and particles are emergent from that bookkeeping, then minds, those intricate patterns of activity, are emergent as well. The feeling of being, the taste of colour, the ache of loss, these too would arise from patterns written in the code. Does that make them less real? No more than learning that a symphony is a pattern of air makes the music vanish. Experience is how the pattern feels from the inside. If black holes breed interiors, and interiors breed complexity, then countless consciousnesses may bud in countless rooms, each isolated by horizons, each awake in its own weather of time. Time itself stretches and shrinks near horizons. For those outside our enclosure, if such observers can be meaningfully imagined, our entire cosmic history may appear to play out in a flicker. For us, from within, the ages are spacious and real. This is not contradiction. It is the ordinary relativity of clocks that ride different paths. It also explains why the wall that holds us cannot be found with a telescope or reached by a voyage. It is not merely far, it is defined by what cannot return. No quantum trick rescues us. No wormhole escapes the rule. Shortcuts, if they exist within our room, only take us from one interior locale to another. They do not pierce the boundary that defines the room itself. The valve is one way by construction. There is a melancholy in that certainty. Our greatest works, our finest equations, our most luminous art, none of it can cross outward to announce that we were here. But there is solace too. The horizon that silences us from the outside is the same horizon that cradled our beginning and kept the newborn universe safe from the parent storms. It gave us time to learn the alphabet of light, to cook in the warmth of stars, to ask questions we cannot finish asking. If wandering through ideas like these, slowly, softly, helps you drift off, while keeping your curiosity warm, consider subscribing to and liking Space Historian. It quietly keeps the lanterns lit for the next night's journey. As we draw near to the steepest ledge of the thought, a final image rises. Recursion without end. Every black hole births a universe that births black holes that birth universes. Upward and downward, through scales the mind cannot map. Layer within layer, rule within rule. Information conserved and recast, horizons enclosing horizons like nested shells. Consider the mathematical implications. Picture the star field we can actually see, a stupendous spread numbering on the order of a septillion suns. Among the heftiest of those stars, the end of life is not a quiet dimming, but a gravitational surrender that leaves behind a black hole. Our own galaxy hosts millions of these dark engines. If even one of them shelters an interior cosmos, and if each of those interior worlds eventually grows its own stars and its own black holes, then our universe is not a solitary theatre, but a nursery, spawning more universes than there are atoms to count within our observable reach. And the story doesn't pause at one generation. Each child room would bloom with its own billions of galaxies. Each of those galaxies would cradle millions upon millions of black holes. Each black hole would unfurl a further interior reality. The tally of universes multiplies level by level, tier by tier, in a cascade that runs downward without end, like a choir repeating a refrain in ever more delicate harmonies. Somewhere within this endless descent and ascent, we reside. The middle of the staircase, neither at the first step nor the last, because there is no first and no last. Our cosmos births from a black hole in a parent universe. That parent rose from a grandparent, and further back still stretches a procession with no origin point, no ultimate source, only a perpetual rhythm of collapse turning into creation. From that recursion springs a startling explanation for the uncanny fit of our physics. Perhaps these constants, the strength of gravity, the masses and charges that define the simplest particles, the speed at which light lays down causality, are not arbitrary knobs, spun at random, but inherited traits, refined through uncountable cosmic trials. Universes whose laws favour star-making, fusion, and eventual gravitational collapse generate more black holes, and so more offspring. Universes that fail to make black holes simply do not continue the line. Over eons upon eons, only those realities capable of complexity survive to reproduce, and the deep architecture of our world carries those successful traits forward. Follow the logic another step, and intelligence becomes not a rare accident, but a near inevitability. Where complexity flourishes, minds eventually appear. Where minds appear, they learn. Where they learn, they build. Given enough time in any universe able to weave stars and planets and chemistry, intelligence rises like a new sense in the fabric. And if every universe that can bear black holes persists and begets, then consciousness is no local quirk. It is a regular blossom on the cosmic vine. We share existence right now with an unbounded multitude of thinking beings, elders in vaster, older parent realities, contemporaries sealed inside the black holes of our own cosmos, descendants and ancestors in endless chains, up and down the recursive ladder. What, then, is the meaning of a single civilization, a single epoch in this boundless genealogy? In such a system, no lone universe owns the center stage. There is no most real level. We are a movement in a symphony that has no final chord, a living phrase in an endlessly creative score where collapse becomes expansion and endings crossfade into beginnings. The basic character of existence is generative. Reality's deepest impulse appears to be the continual opening of new rooms in which new forms of complexity and new ways of knowing can come to life. A quiet reminder while we drift here together. If these gentle voyages help you rest and kindle your curiosity, consider subscribing to and liking Space Historian. It keeps the lanterns lit for the next slow journey through the dark. Stephen Hawking's most famous insight sharpens the horizon of our fate. Black holes, by quantum grace, are not perfectly black. They emit a faint glow, Hawking radiation, whose temperature climbs as mass falls. Small holes evaporate quickly. Colossal ones bleed almost imperceptibly, outliving all stars, but not forever. If our universe lies within the event horizon of some stupendous black hole, then in the parent reality, our entire cosmos leaks energy grain by grain, a trickle no one inside can witness. The timescale for such an evaporation dwarfs our history, 10 to the 100 years and beyond. On that measure, we have only begun. Yet inevitability is patient. As the containing black hole sheds its mass, its horizon shrinks. Inside, the geometry that holds our room steady would evolve so slowly that countless cultures could rise and vanish without sensing a change. But the change would come. Regions nearest the boundary would feel the strain first. Tidal forces, shifting curvature, the slow unmaking of structures that once seemed permanent. Galaxies might fray at their edges. Stars might be unseated. Clusters might melt into streams tugged toward a contracting edge that no one can reach. It is a future drawn in whispers, not shouts, and written on a clock too grand to fear. In that long fade, Hawking radiation would carry information outward, cryptic, scrambled, unrecognizable to us. Echoes of our structures, shadows of our discoveries, distortions of our songs and proofs and names would leak as patterns in a glow no inhabitant here can detect. Is that annihilation? Perhaps not. There are compelling reasons to believe that evaporation transforms rather than destroys. The information woven into our cosmos could survive as a new encoding, seeds that become the first conditions of realities yet to be. In that cycle, a universe does not simply end, it is composted into possibility. Out of its final light, new rooms might open, inheriting faint signatures of all that unfolded within their predecessor. So the phoenix rises again, existence as temporary, but endlessly renewable. Mortality not as erasure, but as contribution to a widening tree of worlds. Life and mind are part of the fuel. We live, we learn, we complexify the laboratory of stars and fields, and in the end our universe surrenders its energy in a way that may prime further beginnings. Turn now to the puzzle of perfect fit. Why the cosmic dials line up just so for atoms to hold, stars to burn steadily, and chemistry to write the lengthy sentences that life requires. The anthropic shrug, we observe a life-permitting universe because only life-permitting universes have observers, answers the letter of the question, but not its spirit. In the black hole lineage picture, the constants we measure are legacies. A parent world could only generate offspring if its physics supported the chain. Gas cooling enough to collapse. Stars forging heavy elements. Cores failing with enough drama to form black holes. The same recipes that make deep time possible also set the stage for life. Our hospitable laws are not a stroke of luck, they are the fingerprints of a lineage that survived. There is an even more provocative twist. If intelligence can alter its environment at astronomical scales, then mind may feed back into the genealogy. Advanced civilizations might influence star formation, manage energy flows, or even manufacture conditions that favor new black hole births. In that speculative arena, universes rich in intelligence would not just be hospitable to life, they would be better at reproducing. Consciousness becomes an advantage in a Darwinian field not of creatures, but of entire realities. The anthropic principle, once merely observational, becomes participatory. We are not bystanders. We are agents who eventually touch the levers that may set the traits of universes to come. With that agency comes responsibility. Our choices, what we build, what we protect, what we learn to shape, may ripple into far futures by affecting the frequency and character of the black holes that bloom within our sky. The constants of child worlds might not be set by whim, but nudged by the grand patterns we encourage or restrain. In such a reading, ethics stretches far beyond our species and moment. It becomes cosmic husbandry across epochs. Now, imagine an observatory that cannot exist. A balcony at the threshold between our room and the parent sky. From there, the outside view would compress our narrative into an instant, a whole history blinking like a firefly before retreating beyond sight. Look inward from that perch and you would witness the turn that birthed us. Matter cramming to its maximum density, then rebounding. Space-time curving, unbuckling, unfolding. The arrow of time taking its first clear step. You would see holography at work, information on a boundary being written, and an interior projection blooming into depth, texture, motion. Our microwave afterglow would reveal itself as the last light of matter crossing a horizon elsewhere, made smooth by origin rather than by a burst of speculative inflation. You would even watch the mechanism by which the room's global geometry imitates what we call dark energy, expansion as a structural fact rather than an added ingredient. But such a balcony cannot be built, not by any craft that obeys the rules inside. The event horizon is not simply far, it is conceptually sealed. No bit crosses outward. We reconstruct the story with mathematics, inference, and the faintest large-scale fingerprints. That is enough to guide wonder, but never to replace it with certainty. A second convergence tightens the weave, the old question of simulation. If a three-dimensional interior can be entirely encoded on a two-dimensional boundary, if the capacity of a region is set by area rather than volume, then the cost of reality looks computational. The laws of physics read like algorithms. Fields and particles behave like stored and updated information. The distinction between a universe and its simulation blurs when the universe is, at bottom, a calculation carried out by the geometry itself. In such a picture, every black hole runs its own program, a complete interior with stars, histories, and minds that experience their world as fully as we experience ours. Nesting upon nesting, simulation within simulation, not as artifice but as the native operation of holographic space-time. Does that rob us of freedom? Not obviously, within the rules of our room, novelty emerges. Creativity is real on its own terms. A symphony is not made less by the fact that air obeys equations. A life is not made less by the fact that neurons obey biophysics. If consciousness flowers from complex information processing, then beings inside any such interior, ours included, are authentically aware. They choose, they err, they learn, they love. The computation is not a prison, but a medium. From yet another angle, our universe resembles an experiment, though no hand need have designed it. The initial parameters were set by the mass, spin, and quantum state of the matter that crossed a horizon in the parent world. The apparatus began crude: hot, dense, plasma, and gravity. Over time, the apparatus improved itself. Stars baked heavy elements, planets condensed, chemistry grew teeth, life tried forms, minds constructed detectors and colliders and observatories. The cosmos learned about itself by raising instruments within, some made of metal, some made of thought. Each measurement is the room examining its own grain. Each insight is the room remembering itself in a sharper way. Exploration is the bias of this whole arrangement. The geometry pushes outward, complexity reaches upward, mind looks inward. Every configuration available under the rules is sampled somewhere, sometime, by some experiment, stellar, planetary, biological, or cultural. Each universe in the lineage is another run, another probe of possibility space. They borrow from predecessors through inherited parameters. They extend beyond predecessors through their own histories and minds and tools. We are both subject and instrument. Our curiosity is not incidental. It is part of the machinery that the universe uses to discover what else it can be. And the discovery does not end with us. Child worlds may carry forward the lessons of their parents, not in language or libraries, but in encoded structure, in the seeds of constants and conditions contained in their birth. Hidden within the structure of space-time itself lies what might be called cosmic DNA, information inscribed at formation, prescribing deep traits and shepherding the long arc toward complexity and consciousness. Imagine that our cosmos carries a quiet inheritance, an invisible script passed down from a world we can never revisit. If we truly dwell within the interior of a black hole, then the deep code that shapes our physics is not a roll of celestial dice, but an heirloom. Call it cosmic DNA. As biological DNA instructs cells to knit tendons, carve eyes, compose nerves and memory, so cosmic DNA would whisper rules to space and time. The electron's mass, gravity's strength, the way light keeps counsel with causality. These are not idle numbers. They are the universe's genes, the motifs that determine how clouds condense into stars, how stars forge elements, how planets emerge from dust, and how, on some of those worlds, awareness learns to speak. That is why the fit feels uncanny. Our laws are not random settings that happen to tolerate complexity. They are traits refined across a long ancestry of worlds, each formed within the hush behind an event horizon, each capable of birthing the black holes that seed the next generation. The code has been sifted by eons of cosmic selection. Universes whose parameters smother complexity never reproduce. Universes whose laws allow radiance, structure, and eventual collapse give rise to offspring, carrying forward the traits that worked. And there is more in the code than bare numbers. The quantum fields that fill space, subtle everywhere, more fundamental than any single particle, act like cosmic chromosomes. They store the instructions for how matter couples to forces, how curvature dances with energy, how space-time flexes when mass leans on it. From those instructions, a simple beginning flowers into intricate form, If James Webb's deep images do indeed reveal a preferred twist in distant spirals, then even direction can be a marker of heritage. A faint bias in the handedness of galaxy arms would be a birthmark. Angular momentum bequeathed from a parent universe, a swirl stitched into the fabric at our inception. In that sense, our sky is a genealogy. We read our origin in the way the farthest pinwheels turn. Most audacious of all, the code appears to include the recipe for minds. The same rules that let stars burn steadily and planets hold atmospheres also permit the rise of information processing structures so rich they begin to feel. Consciousness on this view is not an accident on a lonely shore. It is a foreseeable phase in a rule set that favours depth and nuance. Given enough time, complexity learns to wake. Cosmic DNA also speaks to cosmic reproduction. Just as living beings pass on their genomes, with the faithful copying that maintains identity and the small variations that search the adjacent possible, so too might universes propagate through black holes, preserving essential traits while allowing mutations in constants or field couplings. Across generations, the code explores. It refines what works, it retires what doesn't, and as with biology, there is the tantalizing thought of deliberate intervention. One day, far-off descendants could learn to read the code's alphabet, to caress the constants, to tune the fields, to ease the conditions under which complexity thrives. Cosmic genetic engineering, not breaking the rules of physics but writing in their margin notes. But codes can falter. Some universes may carry sterile instructions, curvatures too steep, forces too skewed, symmetries too strict to permit rich chemistry. Those lineages fail to propagate. Others carry illnesses of a different sort, rules that allow brief flare-ups of structure that collapse too quickly to pass the torch. What survives across the deep genealogy is what fosters durable complexity, and, eventually, what folds gravitational endings into luminous beginnings. That we exist at all testifies to this quiet, relentless selection. We are woven from a thread that did not snap. Something stranger hides deeper in the equations, the possibility that time itself loops. In certain rotating spacetimes, paths exist that curl back on themselves, closed time-like curves, permitted in principle by general relativity. They are not common. They demand extreme conditions and, to persist, would require exotic energy with negative density to prop the loop open. Yet the quantum vacuum notoriously admits brief negatives, a ledger that allows small overdrafts repaid at once. If even microscopic loops flicker everywhere, the cosmos may already be threaded with tiny causal eddies. Imagine the consequence if such loops act on grand scales. The future would not merely descend from the past, it would lean back and influence it. Conditions in the early universe could be, in part, the answer to questions asked far later by minds. Consciousness might participate in its own becoming, not through magic but through feedback. Information processed in the far future, subtly constraining the admissible histories at the bounce, pruning paths that would never lead to awareness and favouring those that do. A bootstrap with the universe's own hands on its bootstraps, effects shaping their causes. A cosmos self-consistent across time rather than strictly linear. This unsettles our picture of choice. If decisions today ripple backwards, then responsibility expands. We are not merely gardeners of tomorrow. We are, in some measure, caretakers of yesterday too. But the mathematics does not force fatalism. Self-consistent loops need not abolish agency. They require that what happens fits into a story that can exist. Within that constraint, the space for choice may remain abundant. We would live then, not on a straight road, but in a spiral, revisiting, refining, ensuring that the conditions for awareness and meaning are met. Step beyond horizons and lineage to a larger web. Perhaps our universes do not stand aloof like islands, but join a network, nodes linked by threads we can scarcely imagine. Quantum entanglement already defies everyday intuition, binding the fates of particles across distance without permitting ordinary signals to run faster than light. Could such correlations subtend horizons? If our interior remains subtly entangled with degrees of freedom in the parent universe, faint statistical fingerprints could persist, correlations so delicate they hide within the noise of the microwave background or the tiniest deviations in particle behavior. Quantum-scale wormholes, non-traversable on human terms, but stable carriers of correlation, might lace the multiverse. No starship could ride them, yet information coded in field fluctuations might seep along those bridges, keeping accounts balanced across rooms no light can cross. In this vision, we are not absolutely alone. We are quarantined with correspondence. Messages would not arrive as sentences, but as patterns to be teased from the sky by minds patient enough, instruments subtle enough, and mathematics honest enough to separate signal from wish. Such a network raises new possibilities and new perils, the chance to share and coordinate across realities, and the risk of patterns that propagate like viruses, reorganizing the rules of distant rooms as they go. If this sounds like computation, that is no accident. The holographic principle whispers that the full tale of any interior can be written on its boundary, and an area, not a volume, sets the budget for information. Reality begins to look like a calculation carried out by geometry. In that light, the boundary that encases us is not only a ledger, it is a processor. The laws we call mathematical are the very algorithms of being. And every black hole runs its own program, an interior where galaxies and minds are both outputs and agents within the computation, as real as anything can be from the inside. Nestings within nestings, each simulation authentic to its inhabitants, each layer both a world and a function. Does this doom free will? Not in the way that matters. Within the rules, novelty erupts. Creativity is not magic, it is the lawful emergence of new pattern. A song is no less real because air obeys equations. A choice is no less yours because neurons obey biophysics. The computation is the canvas, not the cage. All the while, knowledge climbs. Across our history, awareness has extended its reach, from firelight to telescopes, from stones to accelerators, from myth to models that predict and retrodict and, sometimes, surprise even their makers. If this climb continues, it sketches a trajectory towards something like a consciousness singularity, not a machine uprising, but an awakening in which minds enlarge and interlink until understanding approaches the limits allowed by law. The boundary between observer and observed softens. The universe knows itself more fully by weaving its observers together. Such a phase change would not require the loss of self. It could mean the expansion of it, each mind retaining its particular timbre while harmonizing with a broader chorus, gaining access to reservoirs of insight beyond any single skull. With reach like that, the old riddles might begin to loosen. Why these laws and not others? Why such a family of universes? Why this unbroken patience for complexity? Influence could run deeper. Conscious beings might learn carefully to steer initial conditions in child worlds, to adjust the cosmic DNA we bequeath so that future rooms inherit better chances for beauty and breadth, and so we arrive at a crossroad where speculation must answer to choice. If we truly live within a black hole's interior, if faint quantum threads tie rooms together, if awareness tends toward union, then what do we do with the knowledge? One path is acceptance, to live, love, build and wonder within our horizon's honest limits, making the inside rich without fretting over the unreachable outside. Another path is transcendence, to devote effort toward faint channels and subtle codes, trying to turn quarantine into conversation, adding our frequency to a choir we cannot yet hear. A third bends towards stewardship, to think in terms of lineage and inheritance, shaping our cosmic environment in ways that favor the birth of future rooms hospitable to minds. There is also the question of the merger itself. Do we resist the drift toward collective awareness, preserving small-scale meanings even if that constrains reach? Or do we participate, trusting that expansion of self does not require its erasure? The choice is thick with uncertainty. Our evidence is incomplete. Our models are provisional. We could be wrong in every particular and still right in spirit, that reality invites us to choose courses of action under veils that never fully lift. Perhaps that is what consciousness most essentially does. It chooses in the dark with care. It wagers. It writes value into a world that does not arrive pre-labeled. We are not merely readers of the universe. We are co-authors of what comes next. Even if horizons remain inviolable, what we do here matters. It sets the terms of our descendants' days. It colors the code we will pass along. As this gentle journey winds toward pause rather than conclusion, notice what has changed. The facts have not settled. The mysteries have not surrendered. Yet we have been rearranged by the questions. The evidence that our universe sits inside a black hole remains intriguing but not conclusive. The galaxy rotation asymmetry could be an inheritance signal, or an artifact of how we move and measure. The quantum bounce that averts singularities may be the true beginning of beginnings, or a page that doesn't belong in our edition. But the uncertainty is not failure, it is fuel. Science does not end mysteries, it refines them. If we are enclosed, then every black hole within our sky encloses a cosmos of its own. Civilizations thinking their own thoughts under unfamiliar constellations, asking versions of these questions in voices we will never hear. If a consciousness singularity lies ahead, then we live at a hinge, the epoch when minds begin to sense the scope of their role. If a multiverse network hums at the edge of noise, then isolation may be less absolute than it seems. There may already be conversation, thin, statistical, and waiting for us to learn how to listen. Whatever the truth, the constant in all of this is the mind's appetite. We exist mysteriously as the instrument by which the universe wonders about itself. We ask how beginnings begin and why numbers sit where they do. We imagine what cannot be tested and test what once could only be imagined. That we can ask at all may be the cosmos's greatest accomplishment, not because questions guarantee answers, but because questions keep the fire of inquiry lit. Whether our room opens onto infinity or curls within a horizon, we remain beings capable of care, of craft, of discovery, and of the wordless joy that arrives when the night sky feels briefly close. The universe is shy with its secrets, but it has given us the gift of asking, a compass that points not north but onward toward truths that may, one quiet evening, turn out to be beyond our wildest imagination.